the last video, we have learned that we can extend the meaning of sine, cosine, and tangent to angles which are greater than 90 degrees. So that means we should be able to define sine 210 degrees. Now a common question is to ask, what is the value of this? In order to find out this value, by definition, we have to draw a coordinate. And this is our 210 angle. And then we need to make use of our definition for sine theta. We have learned that sine theta should be equal to the y coordinate of P over OP. The problem of this definition is that it is sometimes quite hard to find out the coordinates of P. So without the coordinates of P, it will be quite difficult to find out the value of this trigonometric ratio. And that's why we need to learn the concepts of reference angles and quadrant signs. These two concepts can help us to simplify or evaluate a trigonometric expression conveniently. Now let's take a look at the relationship between the trigonometric ratios and the quadrant of this coordinate plane. Quadrant means these 4 partitions on this coordinate plane. So for a coordinate system, there are 4 quadrants. We call this quadrant 1, this is quadrant 2, this is quadrant 3, and this one is quadrant 4. Suppose now the theta is somewhere here. Then we will say that this green line is called the terminal side. Then in this case, we will say that the terminal side is in quadrant 1. When the terminal side is in quadrant 1, then the coordinates of this point are positive for sure. So that means sine theta has to be positive, cosine theta has to be positive, tangent theta has to be positive. This is just a case we have learned in junior forms. Now when the terminal side is in quadrant 2, then when we consider the coordinates of this point, we should know that the x-coordinate should be negative and the y-coordinate should be positive. Since the y-coordinate is positive, that means sine should be positive in this quadrant. And then for cosine, since the x-coordinate is negative, that means cosine should be negative. And tangent is y over x, so that means that's positive over negative, which will result in a negative number. In quadrant 3, both coordinates are negative. It implies that sine theta should be negative because the y-coordinate is negative, and cosine theta should also be negative. But for tangent theta, since we have negative over negative, we will obtain a positive number. Finally, for the 4th quadrant, the x-coordinate should be positive, but the y-coordinate is negative. Therefore, we can conclude that in this quadrant, the y-coordinate is negative, so sine should be negative. For cosine, since the x-coordinate is positive, cosine theta should be positive. And tangent is y over x, negative over positive, so it is negative. Now we can observe there is a pattern. In quadrant 1, all of these trigonometric ratios are positive, so we can use a letter A to denote this case. In the 2nd quadrant, only sine is positive, so we may use the letter sine, S, to help us to remember this case. In the 3rd quadrant, only tangent is positive, so it means that only tangent, that means T, is positive. And then in the 4th quadrant, only cosine is positive, so it can be denoted by C. Now we have the letters C, A, S, T. This is known as the cast rule. This cast rule can help us to memorize the signs of trigonometric ratios in different quadrants very easily. Now let's take a look at the meaning of reference angles. In trigonometry, these 4 angles are called a reference angle, and it is usually denoted by alpha. By definition, a reference angle is the angle made by the terminal side and the x-axis, and this acute angle is called a reference angle. For example, if theta is 150 degrees, then when we locate the terminal side, it will be somewhere here. And if the terminal side is in quadrant 2, that means this is the reference angle that we are looking for. And so we say that in this case, when theta is equal to 150 degrees, alpha, the reference angle, is equal to 30 degrees. Let's take a look at one more example. Suppose theta is equal to 250 degrees. When we locate the terminal side, it should be somewhere here. Now when terminal side is in the third quadrant, this is the reference angle that we're looking for. And according to this diagram, this angle should be 70 degrees. And that means when theta is equal to 250 degrees, alpha, the reference angle, is 70 degrees. This is an illustration for the reference angle. Here, this blue angle is the reference angle. So if I try to rotate the terminal side for many times, for this angle 2197 degrees, the reference angle is 37 degrees. And this angle can also be negative. So let's say for this angle, minus 1100 degrees, the reference angle is 20 degrees. So a reference angle is always positive and acute. Once we know the CAST rule, C-A-S-T, and the concept of reference angles, alpha, we can have three useful formulas to help us simplify trigonometric expressions. For sine theta, it is actually equal to plus or minus sine alpha, where alpha is the corresponding reference angle for theta, and cosine theta is equal to plus or minus cosine alpha. Similarly, tangent theta can be simplified as plus or minus tangent alpha. Here, the plus or minus sign is determined by the CAST rule. Now let's see how we can apply these formulas. In the beginning of this video, we have talked about this question, the value of sine 210 degrees. Actually, we can obtain the reference angle of 210 first. 210 is somewhere here. And in the third quadrant, the reference angle is here. So that means alpha should be equal to 30 degrees. And in this quadrant, only tangent is positive. So that means sine should be negative. And that means we can obtain that sine 210 degrees should be equal to negative of sine 30 degrees. In junior form, we already learned that sine 30 degrees is equal to half, so that means this one is equal to minus half. We can confirm this result by referring to the calculator. Here we can calculate sine 210 degrees directly, and it should give us minus 0.5. That means our answer should be correct. Let's take a look at another example. In this example, theta is between 180 degrees and 360 degrees, and it is given that cosine theta is equal to minus 5 over 13. Now we need to find out the values of sine theta and tangent theta. First of all, based on the given information, we can conclude that cosine alpha is equal to 5 over 13. Because alpha is an acute angle, so that means this trigonometric ratio has to be positive. In junior form, we have learned that when we have a case like this, we can draw this right angle triangle to represent this case. We can let this angle be alpha and the adjacent side be 5 and the hypotenuse be 13. Then the opposite side can be calculated by considering Pythagoras' theorem. So the length of this side should be 12. Now we should know that sine of the reference angle should be equal to 12 over 13. And tangent of the reference angle should be equal to 12 over 5. Now in order to obtain the values of sine theta and tangent theta, we just need to determine the quadrant sign for sine theta and tangent theta. According to the question, theta is between 180 degrees and 360 degrees. That means theta should lie in one of these quadrants. Moreover, in this quadrant, quadrant 4, cosine should be positive. But here the question says that cosine is negative. That means theta has to be in this quadrant, quadrant 3. In the third quadrant, only tangent is positive. That means sine theta has to be a negative number, and so we can conclude that sine theta is minus 12 over 13. While tangent theta is positive, that means this is equal to 12 over 5. And that's how we can obtain the values of sine theta and tangent theta if the value of cosine theta is given.